Hello everyone, my name is Sibusiso, but I'm also known as Coach Sbu. Welcome into the Mathsbuddies tutorials. Today's video, we're going to be continuing with our calculus questions, and then in this one, we're going to be doing some interpretations. Now notice that here there is no diagram. That's because we're going to be actually using the theory to actually interpret what is happening into the graphs, right? So if you are new to the channel, I would like to welcome you. To a returning ones, thank you so much for coming back, and please don't forget to share these videos, subscribe, hit the notification bell. That way you'll be notified when another video gets uploaded. So without wasting any further time, let's go straight into our instructions. Now the question 8 instruction, they go as follows. Now here it says consider the graph of g of x, which is equals to x cubed minus 3x squared, and h of x, which is equals to minus 2 over 3x minus 4 over 3. I like that, straight to the point. Now the first question here, it says determine whether the graph of h intersects the graph of g at its point of inflection, right? Now we need to show all necessary calculations. Now here, the key word here, it is actually this word, point of inflection, right? So now basically what the question is trying to say here, it says we need to see if this point or this graph, sorry, the cubic function, does it intersect this straight line at this point of inflection, right? So which means now in order for us to do that, we need to actually calculate that point of inflection and then see if that point of inflection is actually the same point as the point that we will get in our straight line. Now, how do we do that? So in order for us to get that, the first thing that we're going to do, we're going to first, of course, take our graph, which is the cubic one, like that, and then we're going to discuss a point of inflection. So firstly, I'm going to write my equation like that. So now we know that when you're talking about the point of inflection, so I'm going to write it as POI, we always say that the second derivative of a graph should be equals to 0, right? Now this helps us to find the x coordinate. Then now to find the y coordinate, we'll have to take that x coordinate and put it back into our original graph. So here, let's go ahead and basically see what is going to be our second derivative. Now in order to do that, we'll first have to calculate our first derivative. Then now here we'll see that this is going to be 3x squared minus 6x, and then from there we'll calculate our second derivative. That's where we're talking about our point of inflection, and then this is going to be 6x minus 6. Now at the point of inflection, so I'm going to write it there again, we state that the second derivative should always be 0. Now this means here that 6x minus 6 is equals to 0. Then now 6x is equals to 6. Now dividing both sides, it means x, it is equals to 1. Now this is the x coordinate of what? Of the point of inflection. Now here, to get the y coordinate, we'll then substitute that x coordinate into our original equation. Now always remember that whenever you're dealing with finding a point, you always use the original equation, right? So now here, when we are substituting here, minus 3 into 1 squared, we get our point, which is minus 2, right? So now here we're getting minus 2. So this means now our point of inflection, right, it is 1 is to minus 2. Now we know our point of inflection. Now the question here, it said that we needed to test whether the graph of h will intersect the graph of g at that point. Now, how are we going to do that? Or how are we going to know if this will basically intersect that? Now, in order for us to do that, right, to check if they intersect, I'm just going to write it like that, check if they intersect, we're going to take the x value of this point and see what is going to be our y value, right? Now, we're going to put this x value on h. Right, we're going to put this x value on h, and then if the value it is minus 2, then it means they do actually intersect, because by intersecting, that means now they will share what? The same point. Now let's go ahead and do that. So our h of x, it is minus 2 over 3x minus 4 over 3. Now by substituting the value, we'll get minus 2 over 3 into 1 minus 4 over 3. Alright, so now let's press this into our calculator. So minus 2 over 3 into 1 minus 4 over 3, and then this means here we're getting minus 2. Therefore, we see here that we're still getting the same point that we get as what is our point of inflection. Therefore, it means that the answer will be yes, they intersect. And that's how we answer the first question. Alright, so now let's go ahead and do the second one, which is second question, which is 8.2. Now the 8.2 here, it says determine the stationary points, right, of y is equals to g prime x. Alright, so now here it says now we need to actually classify the stationary points as either the maximum or the minimum. Alright, now how do we then do this? So firstly, in 8.2, we are given a function, right? And this function, it is y equals to g prime x, right? Now g prime x, notice that this is a derivative of g, right? So this basically means now here we are given y as 3x squared minus 6x. Now if you're wondering where did I get that, remember earlier we calculated our first derivative there, and then we said that it was 3x squared minus 6x. So all I did here was to basically substitute the space where there was the derivative of g, and then actually put it the value as that. So now we have this function now at this point. Now here we need to determine the stationary points of this equation. Now stationary points are the same as stationary points, let me just write it here, is the same as the turning point. And when we all know that at the turning point, the derivative, it is always 0, right? So now basically here, what we're going to do here is then we're going to calculate our derivative, and then we will see that it is 6x minus 6, and therefore we will say our derivative is equals to 0, and therefore we will say 6x minus 6, which is our derivative, this is equals to 0, and then 6x will be 6, and then therefore dividing both sides by 6, x will be 1, right? Then now, because of we have this, now it means now we need to actually find our value. Now remember, I say that whenever you're getting an x value, right, you always take it back into our original equation. Now in this case, you might be confused and think that the original equation is g, but then remember, this is not the original equation. The original equation that we were given, it was y equals to g prime x. Now this then means now we're going to basically take this back into what we had earlier as our original equation. So it will be this equation here. Therefore, when we substitute here, we will then get our value as y equals to, go to calculator, 3 into 1 squared minus 6 into 1. Alright, and then you see that our value, it is minus 3. Now this means now the stationary points, again write it as TP, it is 1 is to minus 3. Now the next thing that the question asked was that we need to actually classify whether these stationary points, right, we need to basically classify whether this is a maximum or a minimum, right? Now in order for us to classify, right, I'll say therefore, let me just use a different color here. Therefore, to classify, what we're going to do is we're going to take our equation and then have a look at it and basically analyze our equation, right? Now first of all, this is a parabola, right? So we know that the parabola, that if the value of a, right, it is less than 0, right? If it is less than 0, it means you have what? A maximum, right? And then if it is more than 0, or if it is positive, it means you have a minimum. Now this value here, we can see that it is what? It is positive. So therefore, right, 1 is to minus 3. Because of this is positive, this means now this is going to be our minimum. And that is how we get our value here, or our final answer. All right, so now let's go ahead and do 8.3. Now 8.3 here says and hence or otherwise. Now the word hence or otherwise, it basically means now that whatever that we just did now, we need to use it, right? So now here it says now we need to determine, right, the values for x for which g is concave down, right? Now in order for us to find that, we can actually, without confusing each other, we can actually discuss what does it mean to be concave down, right? Now the word concave down, it means that our second derivative, right, needs to be less than 0, right? So that's what that means. So now this means now, if you remember earlier, we had already calculated our second derivative, right? So we know, therefore, we know, right, that g prime prime x is equals to 6x minus 6. So therefore, if we're saying g double prime x is less than 0, then this means now 6x minus 6 is less than 0. So from here, we will then solve for x. So by doing that, we'll get x is less than 1. So it means now this is the final answer where we get our concave down. Now, this was 8.3.1, so let me just write it as 8.3.1. And then on 8.3.2, they said now we need to determine the gradient of the tangent, right, to g at its point of inflection, right? So now what are we doing right now? So right now we are looking for the gradient of the tangent to g, right, to g at its point of inflection. Now what does this mean? So this means now here what we need to do here, right, is we need to go back, right, and figure out what did we mean by point of inflection, right? So we need to start off with finding out what did we say about our point of inflection. So if you remember, in our point of inflection, we said that we get our point of inflection at what? At x is equals to 1, right? But the simple way to do it, we can say that our point of inflection, it means our second derivative is equal to 0, right? So therefore, our second derivative, it is 6x minus 6 equals to 0, means now 6x is equals to 6 divided by 6 divided by 6. Now x is equals to 1. Now this is the x coordinate where we have our gradient of the tangent, right? Now, speaking of the gradient, right? Speaking of the gradient, we know that in cubic function or in calculus, gradient is regarded as what? As a derivative, right? So now what we need to do here, we're going to take our derivative, right, which was, by the way, 3x squared minus 6x, and then we're going to substitute that x value that we know that it is the x coordinate of our point of inflection, and then that will help us get the gradient at x is equal to 1, or in other words, at our point of inflection. Now this means now g prime 1 is going to be 3 into 1 squared, 3 into 1 squared minus 6 into 1, right? Now when we press this in our calculator, notice that we do the same thing here because we had already calculated this. Now this means now g prime at 1, it is equals to minus 3. So therefore, our gradient of the tangent, it will be minus 3. All right. Now this will be at the point of inflection, and that is going to be our final answer. All right. Now let's go ahead and look into our final question and understand what the question says, right? Now the question here, it says, determine the value, right, of k if the graph of g is shifted so that the values of x for which the new graph p of x is going to be that decreases, right, is between minus 3 and minus 1. All right. Now here I need you to understand this, right, because this is the part where they try to make sure that they confuse you, right? So what is happening here? So here we have our graph of g, right? Now this graph of g, of course, because of it's a cubic function, there is some part of it that are increasing and some part of it that are decreasing, right? So now currently there is a certain point that we know that it is decreasing, which is g, right? There's a certain point where we know that it's decreasing, but then now this graph, right, it has then been shifted by k units, right, in such a way that this old area where it was decreasing, it has been shifted into -3 and -1, right? Now they say now we need to actually calculate what is the value for k. Now how are we going to do this? Now in order for us to do this, we first need to ask ourselves, where is our graph decreasing, right? Where is our graph of g generally before it was shifted? Where was it actually decreasing? Now in order for us to do that, we're going to say that firstly, to decrease, in order for our graph to decrease, it means now its first derivative needs to be less than 0, right? Now because of I can see my equation there, right, I can therefore say that my derivative, it is 3x squared minus 6x. All right, so now to decrease, I will say the derivative, it is less than 0, and then from there I'll substitute my value into that, and then I'll say I'll make it less than 0. Then from here I'll divide by 3 everywhere like that, and I'll have x squared minus 2x less than 0, and then I'll calculate the factors like that, less than 0, and from there I'll find my critical values, because this is inequalities. So my critical values is x is equals to 0, right, or x is equals to 2. Now because of my arrow it is pointing on the left, this tells me that my value for x needs to be in between the smallest critical value and the biggest critical value, right? Now originally, before it was shifted, right, before this graph gets shifted, we know that actually this graph, right, it is decreasing when x is greater than 0 but less than 2, right? Now let's say now this graph is then shifted, right? So now by being shifted, this then means now when this graph is shifted, it has a new range, right? Because this is the old range, old interval. Now after the graph was shifted, it got a new interval. Right? And that interval was then -3 into -1, right? Now the question now that they're asking us is, what was the value of k that actually shifted this graph so that now it moved from 0 to -3 and 2 to -1. Now by calculation you can see that here from 0 to -3 we actually subtracted by 3, right? From here you can see that we subtracted by 3, and so as from here, right? So what I can do is I can actually put here something just to make it easy to say here we subtracted by 3 and here we subtracted by 3. Now by subtracting by 3, we understand that according to our graphs, right, if k is positive, right, it means that my graph is actually shifted to the left, right? And if k is less than 0, that means it is shifted to the right, right? So now by the looks of things here, we can see that this graph, it went to the left. Now because of it went to the left side, this then means that the value for k, which we shifted this graph with, it is actually 3 units, right? Or it is just 3. Let me just write it as 3 units. It is 3 units because now, because of it was 3 units, or because of it is 3 units, it then means now when we go back into that equation of p of x, right, it would be something like x plus 3 into cube minus 3 into x plus 3. Now this 3 is the one that tells us that this graph is actually shifted 3 units to the left, which will basically give us that answer. And that's it for